2018 paper 1. So here we have an algebra question where we're looking to solve the simultaneous equations. So with all our simultaneous equations, the first thing we always do is call them equation 1, 2 and 3. And then we look at which variable we want to eliminate first. So taking one variable at a time. So I'm going to go with equation 1 and 2 and I'm going to eliminate y, because if we look at equation 3 there is no y. So therefore we can use 1 and 2, eliminate y, and then use that new equation and eliminate another variable then with 3. So if I look at 1 and 2, to eliminate y, I'm going to have to multiply the first equation by 2 and the second equation by minus 3, so that we have same coefficient but opposite signs. So therefore we have 2 by 2x is 4x, 2 by 3 is 6y, 2 by minus z is minus 2z, and 2 by minus 4 is minus 8. So that's equation 1. And then if I multiply the second equation by minus 3, that gives me minus 9x minus 6y minus 6z equals minus 42. And that's equation 2. So if we now add, my 6y's are gone. So we have 4x minus 9x is minus 5x, minus 2z minus 6z is minus 8z, and minus 8 minus 42 is minus 50. So we're going to call that new equation A. And then we're going to take equation 3 and equation A, and we're going to eliminate another variable. So I'm going to multiply equation 3 by 5, and then I'm going to eliminate the x's. So that'll be 5 by x is 5x, 5 by minus 3z is minus 15z, and 5 by minus 13 is minus 65. So that's equation 3. And then we have a is minus 5x minus 8z equals minus 50. And then if I add those, my 5x's will cancel. And then I have minus 15z minus 8z is minus 23z. And minus 65 minus 50 is minus 115. And therefore, if I divide across both sides by minus 23, that gives me z equals 5. So we have our first variable, z. So we're going to now work backwards. We're going to sub z either into 3 or a. So I'm going to sub it into 3. And if I sub it into equation 3, we have x minus 3 times 5 equals minus 13. So x minus 15 equals minus 13. And therefore x equals 15 minus 13, which is 2. So now we have our second variable. So we just need to take those two variables now. We're going to sub z and x into 1. So subbing into 1, we have 2 times x, so 2 times 2, plus 3y minus z, so minus 5, equals minus 4. So I have 4 plus 3y minus 5 equals minus 4. And if I bring everything to the right-hand side there except for 3y, then that leaves me with minus 3. And dividing both sides across by 3 gives me minus 3 divided by 3, which is minus 1. And of course you can check by subbing back in x, y and z into any of the equations, and the left hand side should equal the right hand side. So nice straightforward simultaneous equation that year, and it was 15D for that question. So we had 0, 5, 7, 11 and 15 were the marks that you were getting and accumulating for that question. So looking at B next. So in B we had our inequality, and it's a fraction inequality question, and we can see we're told that x is not equal to minus 2, and it can't equal minus 2 because at this point what would happen is we'd get 0 as the denominator, meaning it's undefined when x is minus 2. Now to solve these inequalities we always have to be careful because of that inequality sign. So most students will kind of multiply across by x plus 2 there, but I don't know if x plus 2 is positive or negative. So therefore that would affect the inequality sign. If it was negative, it would cause the inequality sign to change. So to overcome this problem, what we're going to do is we're going to multiply both sides across by x plus 2 squared, because that is definitely positive, and therefore it will not change the inequality sign. So on the left-hand side there, x plus 2 will go into x plus 2 squared. So that's 2x minus 3 times x plus 2. And on the right-hand side, if I square out the brackets, I have x squared plus 4x plus 4. So multiplying out the brackets on the left-hand side gives me 2x squared plus 4x minus 3x minus 6. And on the right-hand side, 3x squared plus 12x plus 12. Bringing everything to the left-hand side then, we get x squared plus 11x plus 18, and then of course inequality sign will change. So I've brought everything to the right-hand side there, and then I'm reading left to right, okay? So 3x squared minus 2x squared is x squared, 12x minus 4x is... 12x minus 1x, I should say, is 11x, and then 12 plus 16 is 18. So we end up with 0 is greater than or equal to x squared plus 11x plus 18. In other words, x squared plus 11x plus 18 is less than or equal to 0. So what that basically means is that the whole function is less than or equal to 0. In other words, we're looking for where is the y values below the x-axis, in other words, negative. So to solve for that, we're going to let the quadratic be equal to 0. And we're going to solve by factorising. So we have what multiplies to give us 18 and also give us 11. So that must be 9 and 2. So we're replacing the 11x there with the 9 and the 2. So we have x squared plus 9x plus 2x plus 18 equals 0. And if we group the first two and group the second two and take out the highest common factor, then I have x times x plus 9 plus 2 times x plus 9 equals 0. And x plus 9 then is the highest common factor, leaving us with x plus 2 equals 0. So we take out the highest common factor a second time. So by letting both of these factors equal 0, because their product is 0, meaning one of the factors is 0 or both are 0, then that leaves us with x equals minus 9 or x equals minus 2. Now this is not the end of the question, so sometimes we find students will leave their answer as this, but we have to remember that this was an inequality. So therefore, in order to solve, the easiest way to do this is to actually look at what was this function. What does it look like on a graph? So because it is a quadratic, so x squared plus 11x plus 18 is a quadratic. It's a positive quadratic, and it cuts the x-axis at minus 9 and minus 2. And it's less than or equal to, so therefore they are full circles on those values, not empty circles. If it was only less than 0, we would put empty circles there. And we're looking for where is y less than or equal to 0. So in other words, if I go to minus 2, my y value is 0. And if I go past minus 2, so minus 3, I find my y value is negative. If I was to minus 4, my y value is negative. Minus 5, my y value is negative. Minus 6, minus 7, minus 8, my y values are negative. But when I get to minus 9, my y value is then 0. And if I was to go to minus 10, my y value would now be above the x-axis, in other words, positive. So therefore that means that in order for us to get a negative y value, we must be only getting an x value between minus 9 and minus 2. Okay, so therefore that means that our answer is x lies between minus 9 and minus 2. But if I go back to the start of the question, we have this piece of information here, which is crucial, that x cannot equal minus 2, because that would make the denominator here 0 and therefore undefined. So therefore we have to go and we have to remove the equal sign there in our answer, because it cannot be equal to, it can only be less than. And again, often students miss that little key piece of information and write it as minus 9 less than or equal to x less than or equal to minus 2. But the answer is in fact minus 9 less than or equal to x less than minus 2. So we should put an empty circle at minus 2. Okay, so 10 marks going for that question, and it was a 10D. So that's 0, 3, 5, 8, 10. So again, 25 marks in total.